Hello everyone, welcome back. So in this video, I want to talk about how to solve linear equation. It is in section 1.5 of the textbook graphical approach to college algebra. But before we go into the general approach of how to solve linear equation, I want to talk about the definition of a linear equation. What linear equation look like and how to recognize linear equation. How to recognize an equation is linear equation. Okay, so let's get started. Section 1.5. Excuse me. Okay, linear equation. Right. So I'm gonna go to the first part of our lecture today. The first part, I would like to talk about a definition of linear equation. An equation is linear equation if it is in the form why is this color? I'm sorry, it should be this color. Okay, the linear equation is the equation that in the form ax ax plus b equal 0. Excuse me. So in this case, AB equals C. I'm sorry, not is equal to 0. It could be equal to 0, but in this case, because I'm talking about a general formula, so it must be in this form: ax plus b equals c. If you see any equation and you can simplify it to this form, so or originally it is already in this form, then you know right away it is a linear equation. ABC in this case just a number, just constant. It means that it could be whole number, negative number, positive number, could be fraction if you want to. And A, B, and C over here, it could be 0. But however, we barely see that the A over here equals 0. We barely see the most of the time we see is maybe the B might be 0 or the C might be 0. I can give you some example really quick here. I have something like this: 2x plus 3 equal 9, for example. So this is a typical example of linear equation: a equal 2, b equal 3, and c equal 9. Or it could be negative or positive. You want to negative minus 3 equal negative 7, for example, or positive 7. Or if c equal to 0, okay, example 1, example 2, or if c equal to 0, if c equal to 0, then we may have equation something like this: 4x plus 5 equals 0. Okay, and if b equals 0, then the equation could be like this: negative 3x equal 12, for example. All of this equation here is also their own linear equation. Or I can have something with parentheses. For example, in this case, I may have like 2x plus 5 minus 4 x minus 1 equal 7x plus 2. This is a linear equation too, even though that you have parentheses. And if you have parentheses, then you just go ahead and apply the distributive property, right? I mean, you start following them. Or I have something with fraction if I want to. For example, 2x plus 1 over 3 plus x plus 3 over 5 equal 4x, for example. So this is also a linear equation, even though this is in a fractional form. as long as the x variable is in the numerator, then it's okay. But if the x is in the denominator, then it's not linear equation anymore. Okay, so because this over here 4x over 1, so the x over here is still on numerator. Or I can have something crazy like this if I want to. For example, like square root of 3x plus square root of plus square root of 5 equal square root of 7. This one also linear equation because it's in the form ax plus b equals c, but you have to be careful when you subtract both sides by radical. Okay, maybe as long as you know how to simplify radical, then you should be able to do this. So at the beginning of this course, I'm not going to give you something like this with radical. Okay, or I can have something with bracket and parentheses at the same time. For example, 2 plus square bracket 2x minus 4 plus 5 bracket equal something with 2 negative x minus 4, something like this. So all of this is typical example of linear equation. Okay. And I can add fraction as many as I want to. For example, over here I can change this 5 over 2. It's still linear equation. Okay. Okay. Now on the second part of our lecture today, I want to talk about the method of solving linear equation. Okay, method of solving linear equation. And on the first part, I want to talk about some property you might have to use during the process of solving linear equation. The first property I call addition property. So the first property is addition property. Addition. What addition property says? It says that if we have a linear equation A equal B, okay, and if C greater than 0, then if you add C to both sides of the equation, it should give you the same. So A plus C equal B plus C. Okay. Well, it totally makes sense. You know, if you have something equal, then you add to something with the same number, then of course it's equal, right? This is very important because during the process of solving linear equation, you add in a number to both sides, or you subtract a number to both sides, and your equation is still the same. Okay, after you add a number, the statement after you add a number and the original one should be the same. Another equation, another property is called multiplication property. Okay, multiplication property. Okay. Okay. So what if I have again? If I have A equal B and if C greater than 0, then if you multiply this equation here, A equal B here, by number C, both sides, then it should be the same. This and this are the same. Okay, this and this are the same. Or if you multiply by the reciprocal of C, you will A equal B and C greater than 0. So if you multiply both sides by a reciprocal of C, meaning 1 over C, and then it should give you the same, because 1 over C over here is actually, so I put the equivalent statement right here, so I mean A over C equal B over C. It means that if you have A equal B, then if C greater than 0, then A over C equal B over C. So this property here that we use so many times. Remember when we said add and multiply both sides by a number, or you divide both sides by a number to get the x. You know, that's where you're gonna apply this multiplication property. And the last property is most of you already know, this is distributive property. It means what? It means that if you have A times B plus C, then this is equal to A times B plus A times C. Okay, so basically you start falling down. Okay, so after you know this property already, I want to discuss about the general approach of how to solve a linear equation. Maybe some of you doesn't like this approach. Maybe you can start at any linear equation with another way. That's fine. But if you guys follow this general approach, then I'm sure that 98% you get linear equation right. Okay. So what is my general approach? The first step every time you want to solve linear equation is that you always want to apply distributive property every time you see parentheses. So applying distributive property if having parentheses. Well, if you don't have parentheses, then you don't have to do the first step, right? The second step is that combining line term on the left side and right side of the equation. Alright, so you have to combine line term. Combine line term, like if you have on the left side you have 2x and 3x, then you combine them up, become 5x. Now, step number 3 is that isolating variable term, okay, to the left side, okay. Constant term means just a number, constant term to the right side. Okay, some students want to put variable term to the right side and constant term to the left side. Variable term is just the term with variable, for example 2x, 3x, something like that. But most of the time I recommend students to do variable term to the left side. And the last step is to, of course, go ahead apply this one to get the x. Apply the multiplication of the reciprocal of a number to both sides of the equation to getting the x, this x variable. Okay. All right. Now let's go through example. Let me solve this for you. Let me solve the easiest one first. 2x plus 3 equals 9. Okay. 2x plus 3 equals 9. So you see that this equation is very simple equation, and we don't have parentheses, so we don't need to apply distributive property, right? So we just combine line term on the left. On the left over here, there's nothing to combine. 2x plus 3, there's nothing to combine. Number here we don't have to combine either. It means that we just need to isolate variable term to the left. So all variable term is on the left side already, but this constant term is still on the left. So we're gonna move it to the right. So in order to do so, we're gonna subtract both sides by 3. So if you subtract both sides by 3, cancel. So 9 minus 3 equals 6. So usually in your high school, your teacher usually put like this, and he crossed like this, right? But this is college, so I'm not gonna do this anymore. Okay, if I say that subtract both sides by 3, then you know this, then you can do mental math here. All right, then you're gonna divide both sides. Then you're gonna divide both sides by 2 in order to add to get x, right? Because it's that's step number 4 right now. So in order to get x by itself, because this is 2, right, we need to get rid of number 2, and this is multiplication. If it's multiplication, we do division. So you divide both sides by 2. 2x is like 2 times x. So the multiplication, we do division. Divide both sides by 2. 6 divided by 2 equal 3. There you go. So this is the solution for the first equation. Example 2. Okay. On example number 2, I think we're gonna do this one. 2x plus 5. 2x plus 5 minus 4x minus 1 minus 4x minus 1 equal 7x plus 2. So right now you see that this one has parentheses, so we have to do the first step. First we need to distribute it. Okay, so give you 2x minus 10. When you distribute, make sure you have to distribute the side to negative 4 times x is negative 4x. Negative 4 times negative 1 is positive 4. Alright, so I distribute the side to. Okay, distribute this. So equals to 7x plus 14. Now you see the step 2 is to combine line term on each side. So this and this I can combine. 2x minus 4x is negative 2x. Negative 4 plus x is negative 6 equals 7x plus 14. Okay. Then isolate variable term to the left side. So this is variable term over here already, but over here we still have variable term. So we're going to go ahead and subtract both sides by 7x. So after you subtract both sides by 7x, negative 2x minus 7x is give you negative 9x minus 6 equal 14. Then the constant term to the right hand side. So this constant is still on the left, so we're going to move it to the right. So I'm going to add in both sides because this is minus, so you add. Okay? If it's minus, you add. If it's multiplication, you divide. If it's addition, you subtract. Remember that. I'll give you, add both sides, give you 20. Now it's a multiplication, right? You divide both sides by negative 9. So your answer will be negative 20 over 9. Okay? Should be very simple. Alright. On example number, on the next example, example number 3, I'm gonna do this for you. 2x plus 1 over 3. So example 3. 2x plus 1 over 3. Okay. Let me go back. Plus x plus 3 over 5. Plus x plus 3 over 5 equal what? Equal 4x. Okay, equal 4x. Alright, every time you have fraction like this, when we see that in order to combine this, and this is fraction with different denominators, so you have to find LCD. Okay, you have to find LCD. So over here is LCD should be 15. It means that you must have the same denominator by multiply over here by 5, by 5, by 5, by 3, by 3, right? So let me rewrite this. So 2x plus 1 over 3 plus x plus 3 over 5 equal 4x. So I'm going to just go ahead multiply by 5. So when you multiply the top by 5, make sure you put parentheses. So multiply over here by 3 and multiply here by 3. You see that when you do so, you have the denominator equal 0, right? The denominator equal 15. So you have 5 2x plus 1, right, over 15, right? Plus 3x plus 3 over 15 equal 4x. And now you see that this is the same denominator already. You can combine them as one fraction only. So this is 15. Now we're going to combine them. You know, some student really good and he start distributed, that's fine. Okay, so after I combine them, then I distribute. So this is equivalent to I'm going to distribute 10x plus 5 plus 3x plus 3 over 15 equal 4x. Alright, and now we combine on the numerator, so give you 13x plus 8 over 15 equal 4x. Now there's from this step on, there are two different approaches. It's up to you. You can go ahead, bring everything to the left hand side and keep 0 to the right hand side by subtract both sides by 4x, or you can put this as fraction. Okay, if you put this as fraction, what you have is the proportion. So this is a recall right here. The proportion is in the form a over b equals c over d. If you have proportion, I mean you have two fractions and between them equal sign, you can do a cross multiply, mean a times d equal b times c. Okay, so I'm going to apply this in this case. So this is a, b, c, d. So I'm going to go ahead cross multiply. So I have 13x plus 8 times 1 is nothing, equal 15 times 4x. Okay, so we have 13x plus 8 equal 60x. Alright, then I'm going to subtract both sides by 13x. So 60 minus 37, 47x. Okay, then I can rewrite this is 47x equal 8. This is multiplication, right? 47 times x. So in order to get rid of 47, you divide both sides. So your answer will be 8 over 47. And no matter what equation you solve, even though this is a very basic linear equation, you always want to go back and check. You always want to plug them back and check. You know, even the very basic one, very simple one, like last time I did it for you. You want to go back and check. You see that you plug 3 over here, 3 times 2 is 6, 6 plus 3 equals 9. So both sides the same. It means that you got your answer correctly. If you look at it and you see something that doesn't make sense, it means your answer is wrong. But most of the time, if you do carefully, then your answer is correct. Because sometimes, believe me, it takes time to check, and during the test you don't have time. So make sure that when you do the problem, you do carefully. If you do carefully, you don't have to check. Okay. All right, that's example number 3 with fraction. Now let me do this one for you. This one is kind of with bracket and parentheses at the same time. Let's do that. So example 4, right? Example 4. Let me see if I remember the question or not. 2 plus bracket 2x minus 4 plus 5. Okay. 2 plus bracket 2x minus 4 plus 5 equal 2 times negative x negative 4. Equal 2 times negative x negative 4. Alright, so every time you see bracket, okay, you always start from inside out. You always start from inside. You see in front of the bracket over here, actually it's just an invisible number 1. We don't put it, but you know that it's invisible number 1. Okay, but it is invisible number 1. When you distribute it, give you the same thing. So basically you have to start from inside here, so you're gonna keep it. Alright, so I'm gonna start from inside, and you go ahead and distribute it from inside here, so give you 2x minus 8 plus 5 equal to negative x minus 4. Then I'm going to combine line term because right now it's a bracket, so you can change it to parentheses. So 2x negative 8 plus 5 negative 3 equal. Now you can distribute this. 2 times negative x is negative 2x. 2 times negative 4 is negative 8. And now we get the invisible number 1. I just keep invisible number 1 over here. Invisible number 1 here, invisible number 1 here. So 1 times 2x, and just 2x. 1 times negative 3 is negative 3 equal negative 2x negative 5. And now you see that, you have you see at the beginning it's very complicated, but you see after we distribute it and combine like term, everything seems to be easy, right? So we can combine on the left hand side. We just follow the general approach. So we have 2x minus 2, right? 1 minus 3. Negative 2x plus 8. So I'm going to add both sides by 2x because we need to move all the variable term to the left hand side. So we have 4x minus 2 equal negative 8. So I'm going to add both sides by 2. So give you negative 6. So x equal negative 6 over 4, which is negative 3 over 2. And this is your answer. Okay. Okay. I guess that's it. You should be opposed to more. So I'm gonna give you one more example, but I'm gonna let you guys do this time. Okay, I'm not gonna show it. So this is kind of a practice problem for you guys. But for this time, maybe I'm gonna add like a couple more fraction. So 1 over 3, and I multiply by x minus 2 equal 2 bracket 3 3x minus 1 plus 1 over 2 minus plus 4x, for example. Alright, so this one you go ahead and distribute it, and this one you go ahead inside distribute it, and you combine later. But you see that when you distribute this, you have fraction multiplied by fraction. I already asked you to review for that. And when you distribute it, you have a number add a fraction. You must be able to remember how to add fraction, subtract fraction, multiply fraction, and divide a fraction. Those are the very basic concepts I want you to memorize. Okay, so go ahead, have fun with this. I'm gonna leave over here. But if you watch this lecture and you start solving this example here, okay, if you have trouble, you can send me a message through Canvas. Okay, I'm going to show you how to do this. But this is the practicing problem for you after learn this solving linear equation concept. Okay, and that's all for today. I'll be seeing you next time in the next video. Bye bye.